So this is the second part of section 1.3 that we're doing. So on page 17, the first problem, it says that the cost of parking in a parking garage in Chicago is represented by this equation, y equals 15x plus 20, where y is the total cost in dollars and x is the time in hours. The table shows the total cost to park in a parking garage in Denver. Which city's parking garage charges more per hour and by how much more? Then, after how many hours would parking in both cities cost the same? All right, so any ideas here on how we can start? Because we're trying to compare an equation with a table of values. Yeah, what do you think?
We should find the slope of the given table.
Okay, we could do that. We can find the slope on our own, but these points may not be exactly evenly spaced. So what might be even a better way to find the slope? Do it on what, Anna? Yeah, let's do it on the calculator because it'll give us the average of all those points. All right, so I'm going to have to do some work here. I'm going to clear everything on my home screen. I'm going to go to Stat, Edit. I'm going to go up to the top. I'm going to clear, Enter, up to the top here, clear, Enter. And I'm going to put in my x's of 2, 3, 4, 5. Putting in my y's of 43, 51, 59, and 67. I now want to quit, so I go second mode to quit. I'm going to go back to Stat. I'm going to go over to Calculate, and I'm going to go down to my linear regression. Now, I am going to show you something new. And that is if I want to store this equation. Do you see right here where it says store it? So now it's going to go to wherever I tell it to store. Well, I want it to go into Y1. You might want to jot this down. To store, we go to the store right there. And what I'm going to go to is vars. Go to vars. And I go over to Y bars. And I use function because I'm using a function. And now you can choose whichever place you want to put it into, any of those y values. Which one makes the most sense? Y1, we always use Y1 anyway, so let's just push enter there. And now you're just going to go down to calculate like normal. So if I go down to calculate, I hit enter. So right here it's telling me my equation. But if I go to y equals, now it just puts it in there for me too. Yes?
Yeah.
How did I get what?
So do you go to Stat and you find a line?
Okay, so I go to Stat.
Okay.
I went over to Calc. I went down to Linear Regression,
Yes.
just like yesterday. And then right here where it says Store Regression, then that's where I start doing the vars.
Mine doesn't have
Yeah,
that.
mine doesn't have that.
Oh, you have an older one?
Yeah.
Let me see yours and I'll show you how to do it.
Oh, it said that if you hit bars, then you can just go to Y bars from there. But does that still store it?
Let's see, vars, y bars, function. So I don't know if this is going to work. Let's see. Okay, it did. Okay, so you just, yeah, the older calculators are a little bit different.
So just go straight to bars?
Yeah, go straight to vars. Okay? And I'll come and help you individually, okay, if you need it here in just a second. But it's not a big deal to store that in there. I mean, it's just saving you like 3 or 4 keystrokes. It's not a huge deal. But you know when we get those really long answers that are like, 2.359x, then it's nice to have stored it. All right, so anyway, so we have that equation in there. Now, we also want to put in this equation, right, because we're comparing the two. So I'm going to put in this one, 15x plus 20. If it didn't store it, then just type it in, and then I'll come around and I'll show you how to store it. Okay, now in mine's older. If I go over here, I can change this to bold just so I can tell them apart better. If you have a newer one, it's in color. You don't have to worry about it. Okay, so now what I'm going to do is I want to set up my window, because if I hit graph right now, it's going to just be kind of weird. It's not really what I want to see. So I'm going to go to my window. I don't want my hours to go from 0 to 90. What would make more sense to go from 0 to what? I always like to go a little bit higher just to make sure I see that. Yeah. And then if I'm going to have to check something like 8 hours, though, I'd want to go even higher. I'd want to go at least up to 8, but I'm not going to check that. And then our cost, like, we're not going to pay $500 for this parking meter. Probably like 100, right? At the most. So now we're going to hit graph. So here's our first function, and here's my second function. So now I can really see both of these. And we just found this equation. It was y equals 8x plus 27. So the question is asking us, first of all, which city's parking garage charges more per hour? So which one's charging more? All we have to look at is what?
Which one's higher?
Yeah, which slope, actually. What's the slope here? So this is 15 per hour, and this one's going to be 8 per hour. So the answer would be Chicago by $7 per hour. And then the second part says, after how many hours would parking in both cities cost the same?
1 hour.
1 hour? How'd you get that?
For the cross.
Yep, but how'd you know that's where they cross? Okay, you're right. Let me show you how to have the calculator figure this out. One way I could do it is I could just set the two equations equal to each other, and I could just solve it, right? But another way I could do it is to have my calculator find where they're equal. So I do this second trace again, and I go down to which one would make sense. Intersect. And I go enter, and then it's going to say, is y1 your first curve? I push enter to say yes. Is y2 your second curve? I push enter to say yes. And then it says a guess. You push enter one more time. And it tells us at 1 hour, they're both going to be $35. Okay? So this, if I want to solve something like this, all I have to do is intersect, and that's located under second trace. See, everything we can do on the calculator can be done by hand too. So if you get kind of confused on the calculator, just do it by hand. Okay, it's not a big deal. So we've got that. Now, I want to talk though for a minute about what these two mean. This one is saying I pay $15 per hour, but I have to pay $20 just to even get into the garage. So if I'm only there for 15 minutes, I still have to pay $20. This one, I've got to pay $27 just to get into the garage. So I'm in there 40 minutes, I'm paying $27. But then after that, it's only $8 per hour. Does that make sense, like what the interpretation would be? Now watch this. Let's say I want to know second trace. Let's say I'm going to be there all day. I have to work. And I have an 8-hour work day. Did you see what I did? Second trace, value, 8-hour day, enter. Oops. Do you know why it's invalid?
It's the thingy on, because your window isn't big enough.
Yep. Remember I said earlier I was only making my window 6. I got to make it at least 9 or 8 to be able to see that. So now I'm going to go back. Second trace, calculate a value for, whoops, still not as good. I was going too fast on that part. For 8 hours, and it's going to tell me that it's 91. But here's what's so cool too. I can make it, that's for, what is that one? That's Denver, be $91. I can jump up, and now it'll tell me if X is 8 in Chicago, I would pay $140. That's probably not reasonable. I don't think they'd make you pay that much. Couldn't afford to work if you had to pay that much. All right, so does all that kind of make sense? Practice doing this kind of thing on your homework. Kind of push yourself to not just do things algebraically, but to use the calculator more and more. So this was 1 hour. All right, down here. It says in exercises 5 through 7, use the linear regression feature on a graphing calculator to find an equation of the line of best fit. Find and interpret the correlation coefficient. So let's do it for this one first. Let's go to our stat edit. And I'm looking at my x's, so just kind of follow along. I'm going to do this kind of quickly, so I'm running short on time. But my first x is 1, my next x is 2, this is 3, this is 5, and this is 5 as well. So I have to put 5 in there twice for x. Do you guys see what I'm doing? This x value is 5, this x value is 5. Right with me? I'm going to come over here. My first x value here is 5. X here is 2, x here is 1, I'm sorry, I'm saying x's, but I'm doing y's. Y there is 1, y here is 2, and y here is 5. All right. Now, if I want to see those points, what am I going to have to do? I'm going to want to clear out these lines, first of all, because they have nothing to do with this problem. But do you remember how I turned the plot on? Yeah. So I'm going to just push enter so I can see these. If I don't have my window set up, I'm not going to see them right. My x's are going from 0 to 5, but I'm going to make it 6. My y's are going from like 0 to up to 5. I'm going to make it 6 again. So since I made my window look good, I should see those dots. There they are. Do they look very linear?
No.
No. Let's figure it out. Stat, calculate, linear regression, enter. However you want to do it, I'm going to make it pop in there for me. So I'm going to go to my vars, y vars. So that's going to pop the equation in there, and now I'm going to go down to calculate. All right, so here's what I get. Here's the equation of the best line through there. I don't even need to write it down because it's already in there for me. See how it popped it in there for me?
It's kind of like a line of best fit.
It is the line of best fit. So now when I hit graph, look at that line though. That line's not even touching any points, but what they're doing is they're finding the average of all these slopes, trying to make a line out of that. What would be a better representation for this? X squared, a quadratic, wouldn't it? I want to show you something here. We're not really getting into this yet, but I want you to look back. Stat calc. I'm just going back to this real quick. See how this R is a negative? All that's telling me is that the slope is negative. I really look at this correlation coefficient. Is that closer to 0 or 1? 0. That means this is hardly linear at all. Watch if I did this. Stat, calculate, and look if I did a quadratic on this. We're not really doing quadratics yet, but I'm just going to show you. Now look at our R squared. It's much better, isn't it? It's still not perfect, but it's better than it was before. But like I said, we're not doing that. Okay, so the interpretation of the correlation coefficient, not linear at all. Okay. All right. Do you guys think you need one more, or do you understand that? You guys understand how to put the points in, right? And what do you think this R value is going to be? Do you think it's going to be closer to 0 or 1? 1. Yeah, we don't need to do it. Okay? So if you have any trouble with the calculators, let me come around and help you, see if I can figure it out.